Good morning, everyone. I hope you're having a great week at reInvent. I'm personally really happy to see your happy faces in person. And I'm a product manager with S3. My name is Shaki, and I'm excited to talk to you about best practices for managing Amazon S3 data at scale. As you know, Amazon S3 is the object storage that gives you virtually unlimited scale, while you can focus on growing your data without being concerned about provisioning the infrastructure underneath. And with this, we see that customers often store millions and billions of objects in their S3 buckets. And today, we are going to talk about the best practices for some of the latest tools that S3 offers to help you automate the management of your data at scale. We think that these tools will help you better understand, optimize, and perform actions across your ever-growing storage at scale. So we see that increasingly, customers are transitioning all of their applications to the cloud, while some are just starting ground up in the cloud. And as a result of this shift, more and more data workloads are moving to Amazon S3. Customers are choosing Amazon S3 for a lot of different reasons. For some, it is about the high availability. For some, it's about the high throughput that S3 offers, the scale they can reach with Amazon S3, the 11 nines of durability, the ability to store data across multiple regions with cross-region replication. And for some, it's the wide range of cost optimization capabilities that we offer. And for some customers, it's the security and management features that we offer, giving you the ability to control access at the object, bucket, and account level. S3 is a powerful service for storing your data and to achieve your business goals. So typical business goals are to understand your usage, verify your security, increase efficiency, drive down costs, or migrate data to a different environment. S3 will provide you with tools and capabilities to manage your data at scale. And in the session today, we are going to use a case-based approach to learn about these tools and capabilities that will help you with this. So let's look at the first scenario. Let's say you operate a data lake that is growing at a rate of millions and billions of objects per day. And with the growing object storage costs, your leadership wants you to identify a way to optimize your storage costs based on your data access patterns. How can we achieve this? We will look at two features, S3 intelligent tiering and Lifecycle as storage cost optimization capabilities within S3. But before that, I want to talk about storage classes in S3. So S3 has a concept of storage class, which is set at the object level and has set characteristics like performance, price, and availability. S3 has a number of storage classes to choose from, as you can see on the screen. Whether you have demanding performance needs, data residency requirements, unknown access patterns, infrequently accessed data, or archival needs, S3 will have a storage class that is optimized for your specific use case around data access, durability, and cost needs. So let's start with S3 standard. If you know that your data is active and frequently accessed and may be deleted within a month, S3 standard is the best way to go. It is designed for 99.99% availability, milliseconds latency, and protection against a single AZ loss. Let's say you have a social media app where end users upload photos, but they are infrequently accessed, but will need low latency access when they're actually accessed. S3 standard IA is the best choice in that case. In case of backups that are rarely accessed, but require instant millisecond access when they do, Glacier Instant Retrieval will be the best choice. It is a brand new storage class that we just announced this week. In case of log data that is rarely accessed but needs to be stored for compliance purposes, for example, you can use S3 Glacier Flexible Retrieval and Glacier Deep Archive storage classes. For data that is reproducible and is less frequently accessed, you can use S3 one zone IA, which stores data in a single availability zone and at a lower cost than the standard IA storage class. And then there's Amazon S3 on Outposts, which delivers object storage to your on-premises AWS Outpost environment and helps you meet your local data processing and residency needs. And then there's S3 Intelligent Tiering. That is the most popular storage class with data sets that have unknown and unpredictable access patterns. And I want to dive a little bit deeper into S3 Intelligent Tiering and talk about why it is the most popular choice for data lakes. So S3 Intelligent Tiering storage class is designed to optimize storage costs by automatically moving data to the most cost-effective tier when access patterns change. So for a small monthly object monitoring and automation fee, S3 Intelligent Tiering monitors access patterns and automatically moves objects that have not been accessed to a lower cost access tier. So how does S3 Intelligent Tiering really work? So all data will start in the frequent access tier, which has the same price and performance as S3 standard. After 30 days of consecutive days of no access, data automatically moves from the frequent access tier to the infrequent access tier. And then, if data is not accessed for 90 days, it automatically moves down to the archive instant access tier, which is similar to the S3 Glacier which is similar to the S3 Glacier instant access retrieval that we just announced last week. And in case you choose to activate the archive access tier, S3 Intelligent Tiering will automatically move objects from the infrequent access tier to the archive access tier after additional 60 days of no access. And then objects will move from the archive access tier to the deep archive access tier after an additional 90 days of no access. Like I said before, there are no retrieval fees associated with S3 Intelligent Tiering and is ideal if you have changing or unknown access patterns. Now, just this past September, S3 Intelligent Tiering further optimized storage costs for small and short-lived objects by removing the minimum storage duration for all objects and the object monitoring and automation fee for objects that are smaller than 128 kilobytes. So previously, S3 Intelligent Tiering was only optimized for long-lived objects that had to be stored for a minimum duration of 30 days and objects that were larger than 128 kilobytes. With these changes that were announced, S3 Intelligent Tiering is the ideal storage class for data with unknown, changing, and unpredictable access patterns independent of object size or retention period. And typical examples include data lakes, analytics, or any new applications that you're trying to build in S3. And this is a number that I wanted to share. So since the launch of S3 Intelligent Tiering, customers have saved more than 250 million in costs so far. And this is a number that we look here at S3 and get really excited about because we are passing on this value to you to help you grow your business. And then I want to talk about Lifecycle. When we hear from customers, what we hear from customers is that access patterns for some of their data sets change predictably over time. So for example, you might be uploading and analyzing data that is being actively accessed initially, but is rarely accessed over time, such as backup videos for streaming apps or access logs data. You will want to move such data to colder tiers over time. In this approach, you can set up lifecycle policies to transition such data into a colder storage class over time, such as S3 infrequent access, S3 Glacier instant retrieval, or S3 Glacier deep archive. You can also use S3 lifecycle to expire objects and their older versions based on their age. Lifecycle is great for predictable workloads where objects become colder or less accessed over time. And just last week, we announced 2 new configurations for Lifecycle. The first one is object size filters. So to control costs, when you lifecycle data across different storage classes, you can now choose objects to move to other storage classes based on the size of the object. So for example, you can optimize your costs by transitioning only large media files to storage classes such as S3 Glacier or S3 Glacier Deep Archive. The second announcement was the number of non-current versions for version buckets. So here you can save costs by deleting old or non-current versions of an object by, say, after 5 days when there are at least 2 newer versions of the object. This allows you to have additional versions of your objects as you need, but saves you costs by transitioning or removing them after a given period of time. To summarize, one of the key things about storage classes and storing your data is that you want to optimize for the performance and storage costs over the lifetime of your data. And we noticed that customers generally use 2 design patterns based on how predictable their access patterns are. S3 intelligent tiering for automatic cost optimization between different storage access tiers when the access pattern of the data is not predictable. Or in cases of known access patterns, customer can use S3 lifecycle policies to move data to S3 infrequently accessed storage classes and S3's archive storage classes. Let's move on to the next scenario. Let's say there's a detailed security review for all your objects stored in S3. You will need to provide a compliance report to prove all objects stored in S3 are encrypted. Let's review features that can help you achieve this across your data set. Let's start with storage lengths. Customers are using S3 to store large data sets across tens of hundreds of accounts and buckets that are spread across multiple regions and thousands of prefixes. At this scale, managing, optimizing, and reporting for these shared data sets can become challenging. Customers managing these sorts of environments have told us that they often find it difficult to understand how the storage is used across the organization, how should they optimize their costs, and how should they improve their security posture. And that's why we launched S3 Storage Lens last year to gain organization-wide visibility into your object storage usage. Lens is the first cloud storage analytical solution to provide a single view of object storage usage and activity across tens of hundreds of accounts in an organization with drill down that are ranging from account, bucket, or even prefix level. Storage length consists of a large number of metrics, 29 in total. Many of these metrics have never been surfaced in this way before. The metrics are organized into categories like data protection or efficiency that will help you easily find the relevant metrics that you need for your use case. Lens provides aggregation from the highest level of AWS organization down to the prefix level, like I said before. And these metrics are being refreshed on a daily basis. We also think that Lens is a highly visual interactive dashboard which is available in the S3 management console. And for ease of use, all customers have a default dashboard enabled for them. If you are like many customers, this might be the only dashboard that you need. But if you want, you can make changes. For example, you could configure the dashboard to export the data daily to an S3 bucket for analysis with another tool like QuickSight, Athena, Redshift, or you could upgrade to advanced metrics if you'd like. And finally, recommendations are the icing on the cake that help you flag outlier data points or take action against a particular metric. All these things combined will help you discover anomalies, identify cost efficiencies, and apply data protection best practices across your accounts. Like I said before, you can use storage lens to gather quick summary insights that give you holistic visibility into your storage. And for our specific use case, we were interested in encryption. So in this example, we can focus in on our region distribution in order to learn that 26% of our storage in the US West region is unencrypted. And then we can focus on buckets in that region to kind of take action on them. Now that we have gained organization-wide visibility into our encryption matrix via storage lens, we should also consider setting up default encryption setting for our S3 buckets. With default encryption, you have the ability to set up S3 buckets where data is automatically encrypted by default. It is a one-time bucket level setting where you define your encryption key, whether S3 managed key or a customer managed KMS key, and all your subsequent uploads to your S3 bucket are automatically encrypted. We also launched bucket key configuration last year that will help you reduce your KMS costs by up to 99%. Next, we will learn how we can use a combination of inventory and batch operation capabilities to focus on objects that are existing and are unencrypted in our buckets. So as customers grow their data within S3, they want an easy and automated way to understand what objects are in a bucket and audit them. Like in our specific case, we want to understand more about the encryption status of objects in a bucket. Amazon S3 inventory is a great way to audit millions or even billions of objects in a bucket. With inventory, you can configure multiple inventory lists for a bucket. You can also configure what object metadata you need for your bucket. So for example, creation date, replication status, encryption status, etc. Reports can be scheduled daily or weekly and can be created for entire buckets or filtered for a given prefix. These reports can be configured to output in CSV format, Apache ORC format, or Apache Parquet files, and then can be queried with tools like S3 Select and Amazon Athena. So let's create an inventory report to indicate the encryption status of objects in our bucket. We will need to begin in the management console, in the management tab, and choose the inventory option. Here, we will be able to view any existing inventory reports if they are available, or create a new inventory report like we'll do now. So now we are able to define the details of our inventory report. We will give it a descriptive name, leave the prefix filter field blank as we want to report on the contents of the entire bucket. We can also choose, if we wish to report on versions of an object or only include the current versions. We also need to define where the report will be stored. So for our situation, we will select an existing bucket within the same account as our data bucket. In case your organization has separate accounts set up for segmenting activity based on reporting functions and operational functions, we could select a bucket from another account if necessary. And you can note that this process will append the necessary bucket policy to the defined destination bucket, granting the inventory service the necessary permissions to write the inventory file in that bucket. And then next, we can define if this report will run daily or weekly, choose the output file format, and decide if we want to enable the report right away. And we will choose daily reports in the CSV format, and of course enable the report. But as a side note, when an inventory report is first configured, regardless of whether it is daily or weekly, it may take up to 48 hours for the first report to be generated. And finally, we can decide which metadata fields we would like to include in our report. These are optional, but for our purpose, we need the encryption field. And now we can create a new inventory report and wait for it to complete its first execution. Next, now that we've identified the unencrypted objects in our bucket, we want to use S3 batch operations to create encrypted copies of objects that were identified as not encrypted and needs to be protected. So S3 batch operations provides a scalable way to execute many common tasks across millions or even billions of objects. And because it's a managed service, it runs in the background and will self-throttle to prevent any performance impact to your S3 workloads. And you don't have to write code or set up any server fleets or figure out how to partition your fleets and manage them. Instead, you create a job in minutes through a few clicks, turn it loose, and sit back while S3 uses its massive behind-the-scale parallelism to take care of this job. And here is how it works. You first provide an input into the job, which could be a CSV or an inventory report. In our case, it's going to be the inventory report that we just generated in the previous slide. Next, you select the operation you want to perform. So copy, which is what we'll use for creating the encrypted copies of our unencrypted objects. You could also invoke a Lambda function, providing an almost limitless capability for data handling. You could replace all object tags or access control lists. Note that these operations replace and do not add to an existing configuration. And then you could also use restore, bringing objects back from Glacier, for example. You could modify object lock properties like legal hold and retention date. And then lastly, you could also delete object tags. This is an operation that we just introduced earlier this year. And then S3 does the work for you. The selected operation will take place across each of the objects that you have defined in the inventory report or the CSV. And lastly, you determine how you want to view results and/or track progress. You will have the completion report for yourself once the batch operation job is complete. Here we see a deeper view into a batch operations job. Note that the selection of the operation, the manifest, and the reporting location. The priority allows S3 batch operations to run tasks in parallel while allowing you to set priorities for multiple batch operations jobs within your account. And this API-driven approach makes granular, automated deployment of your batch operations job a breeze. So with this, we have satisfied our requirements of identifying the state of our encryption and creating the encrypted copies of any unencrypted data that we found out. To summarize, you can use storage lengths to get an organization-wide summary of your encryption metrics. You can use default encryption to mandate encryption of all new data to your buckets will be enabled. You can enable inventory report to identify objects that need to be encrypted. And lastly, use batch operations to create encrypted copies of your unencrypted objects. Let's look at the next scenario. Let's say your board of directors insists that all your data needs to be replicated across multiple AWS regions within a stipulated time. And given that you have this multi-region architecture, you want to use it to improve the performance of your applications that are available globally to your users. Let's review features that can help you achieve this. So at S3, we are seeing an increasing need from customers to store their data across multiple AWS regions. And there are a few reasons for this. First is performance. A lot of applications today are global scale applications with users across geographies. And storing data in multiple regions improve performance for these applications since requests from these users can be routed to the storage that is closest to them and reduce latency and optimize performance for your applications. Second is resiliency. Storing data in multiple regions give you resiliency in case of failure with your primary region. And lastly is compliance. We see this a lot with our customers in the financial industry where they have compliance requirements to store data in multiple regions. So let's look at the first feature, S3 replication. It is used by our customers for data protection, and replication enables automatic asynchronous copying of your objects across Amazon S3 buckets. You can decide to protect your data within the same region or across different regions. Amazon S3 will continuously replicate your data, automatically generating that second copy. S3 replication gives you several options. For example, you can replicate within the same AWS region with single region replication, or to a different AWS region with cross-region replication. You can replicate from a single source bucket to multiple destinations. You can also replicate data across different AWS accounts or between buckets with different object lock settings. And if you need predictable replication backed by an SLA, S3 replication time control lets you replicate objects within 15 minutes of upload. Let's dive deeper into this. So if you're a customer looking for predictable SLA-backed guarantee on your data replication, you should consider using S3 RTC. RTC is designed to replicate 99.99% of your objects within 15 minutes of your upload, and with replication typically completing within seconds. You get an SLA commitment that says that 99.9% of your objects will get replicated to your destination bucket. RTC can be applied to the entire bucket or a subset of objects that are filtered by prefix or object tags. Multi-region access points. So if you are considering building a multi-region application or already have one, we recommend using multi-region access points. Launched just a few months ago, multi-region access points makes it even easier to build global applications. They accelerate performance by up to 60% when accessing data sets that are replicated across multiple AWS regions. And they use AWS Global Accelerator behind the scene. So they consider factors like network congestion and the location of the requesting application to dynamically route your data and requests over the AWS network to the lowest latency copy of your data. And this automatic routing allows you to take advantage of the global AWS infrastructure while maintaining a simple client architecture on your side. Multi-region access points use the same flexible replication rules that you use with S3 replication to provide for the maximum flexibility. So for example, you can choose what to replicate, to which destination, what kind of bandwidth to use. And if you're using replication data today, you can simply add a multi-region access point. And if you're building a new application, you can set up your replication rules from ground up while creating that access point. Either way should be fine. Multi-region access points also provide a replication summary to show the result of your replication configuration across all of the buckets in a multi-region access point. If you enable S3 replication metrics in replication rules while setting up this access point, you can monitor your replication progress, including replication latency, bytes pending replication, objects pending replication. And all of these metrics help you build and monitor multi-region applications with the most flexibility to customize your specific client application. So in summary, we learned how you can use S3 capabilities to create a multi-region setup. You can use S3 replication to create secondary copies of your data. You can ensure S3 RTC is replicating 99.99% of your objects within 15 minutes of upload. And lastly, you can use a multi-region access point to accelerate access to your data that is spread across multiple global buckets. Let's move on to the last scenario. Let's say your organization is hosting tens of thousands of S3 buckets across hundreds of accounts. And these buckets have shared data that is often accessed by multiple users. And you're part of the team that is looking for ways to simplify your access management and policy management for cross-account users in the organization. How can you achieve this? We will review S3 features that will help you simplify security management at scale. So first, let's look at simplifying ownership and permissions in S3. In S3, there are multiple ways to grant access to your data. You can use IAM policies, which define what resources the IAM roles in your account can access. Then there is bucket policy, where you grant or deny permission to different users using a bucket policy. This is usually how you define or grant external AWS account access. And lastly, there is access control list, which predates IAM and was the original way S3 granted access to your bucket and object and still exists today. It's an atomic attribute for each bucket and object, and you have to invoke it individually. So cross-account write is a common situation for customers with multiple accounts. And let's use an example to show how this can get complex with customers having multiple accounts. So you own account A and have a bucket that serves as a data lake. Account B wants to write data to your bucket. Now, there are three complexities that you need to pay attention to in a cross-account write situation. First, whenever account B writes to your bucket, account B needs to give you permission to read via an ACL, also known as access control list. Second, whenever account B writes data to your bucket, objects are owned by account B. And third, because you don't own the objects, you cannot use bucket policy to give other accounts access. You have to do that through ACLs or access control lists. And this can present challenges such as enforcing bucket policies to objects owned by the bucket owner in account A. And we think that bucket policy is the modern best practice approach to sharing your data with other users. You use bucket policies to share data with other AWS accounts and create a security perimeter to deny access to other users. And objects written by an external account are owned by that account, even if written in another account, as you can see here. And the result is that the bucket owner A cannot further share that object via a bucket policy with other account users. And we wanted to make this simpler for our customers and in that use case, and are adding a capability to S3 object ownership, a bucket setting that you can apply. It's my personal favorite launch of this year. And this new feature that we're launching is the right answer for nearly all our customers. It's a recommended bucket setting. It does two things. First, it makes sure that ACLs are disabled. Second, it makes sure you, as the bucket owner, own everything that is being written in your bucket. It means that bucket policies will be the only means of sharing data, and ACLs are completely out of the picture. So here you can see that even though account B is writing data to account A's bucket, that data is now owned by account A and can be shared by multiple users, and bucket policies can be uniformly applied. Compared to before, you wouldn't have to deal with ACLs at all. For example, account B writes to your bucket. The write doesn't need to specify an ACL. You own all the objects. You can now use bucket policies to control access for those objects. Next is access points. As you grow your data sets and add multiple shared data sets to your buckets with multiple client access, your bucket policies can become more and more complex and hit their size limit. Amazon S3 access points helps you simplify access management for buckets that contain shared data set. As you can see in this illustration, access points help you divide access for your bucket into multiple groups of users, each with their own access policies in the same bucket. So for instance, you can divide cross-account users into 3 groups: finance, sales, and dev. Each of these groups read data from a designated access point that has its own access point policy. And this summer, we launched S3 access points alias that makes accessing your access points from other client services even more easier. With access points alias, each access point receives its own unique bucket-based alias automatically that can be used to replace bucket name URIs for data access. This means you can use these access point alias for all your S3 API requests to talk to services like EMR and other client services that you might have. And they will automatically connect to access points without requiring any code changes at their end. And the last feature to consider when simplifying security in S3 is S3 Access Analyzer. Customers wanted a way to review their existing permissions and prevent unintended access permission. And for this, we introduced Access Analyzer for S3 a few years ago. This feature analyzes permission for your buckets in an AWS region and provides a simple dashboard that shows buckets with public access as well as buckets shared with external AWS accounts. So let's take an example. When you make a change to your bucket policy, Access Analyzer will identify public access, new access permission added, and any existing permission removed from your bucket policy. And this gives you that confidence that you have made the right change that was intended for that bucket policy. So let's do a simple example. Let's say we have an S3 bucket with an existing policy that allows public access. If you preview access without updating the bucket policy, you can see there is an existing finding for public access. Now, if you update your bucket policy to remove that public access and to only allow one specific external account to read your bucket, you will see 2 findings from Access Analyzer. The first one is you have a new access, and the second one is you have a resolved public access. So this setting helps you make sure that you are applying the right permissions to your bucket and feel confident about that. So that was all about how to manage access and security for your data at scale. Access points, object ownership, and Access Analyzer are 3 tools that you can use to simplify management of security policies at scale. To wrap up, we looked at 4 cases today. We learned how you can use S3 intelligent tiering and Lifecycle to optimize storage costs for your data based on your access patterns. For the case of encryption management at scale, we learned how you can use storage lengths to gain visibility into your encryption metrics, default encryption to mandate encryption for your buckets, and then a combination of inventory and batch operations to create encrypted copies of your data that was not encrypted before. Third, we also learned how you can set up multi-region architecture setup using S3 replication, RTC, and multi-region access points. And lastly, we learned how S3 object ownership, access points, and Access Analyzer can help you simplify security policy management at scale. Thank you for your time, for coming to this session, and for coming to reInvent. We really appreciate your feedback and your partnership through this time and the rest of the year. I hope you have a great rest of your day, and happy holidays to everyone.